morning. Welcome to our next lecture from paper number 1, Calculus of Several Variables, and from the first unit, Limit and Continuity. In the last lecture, we have learned the definition of limit, of course, for a function of two variables, which is known as what? Epsilon delta definition. Now, here in this lecture, let us learn from the definition there itself how to use the definition or how to solve the examples by using the definition of limit for a function of two variables, and then we can extend it for functions of three variables. Okay, to go for directly the examples, let us recall the definition, okay, and then we will have actual implementation of the definition to solve the problem. Okay, as we know, what we have, f of xy has a limit L as xy tends to AB if we choose epsilon greater than 0, then we can able to find out delta greater than 0 such that absolute value of f of xy minus L will be less than epsilon, and this will happen whenever 0 is less than root x minus a square plus y minus b square less than delta. This is what we have the definition of limit of function of two variables. Okay. Now let us go for the application of this definition. Okay. Very first example, show that limit xy tends to 0, 0 of xy over root x square plus y square. This is equal to 0. Okay, let us go for the solution of this one. Okay. Let epsilon greater than 0 be any given number. Okay, let us choose epsilon which is greater than 0, a number. Okay, and now we need, as per the definition, we need to find out delta, which is depending on epsilon, and we satisfy this condition. Delta will satisfy this condition, whereas if we are considering epsilon to be positive, then this will satisfy this condition. Okay, now here in the example, limit xy tends to 0, 0 of this function is 0, and therefore here L is 0, and f of xy is our xy over root x square plus y square. And therefore what we do here, consider absolute value of f of xy minus L, which is what? 0, which is equal to absolute value of xy upon root x square plus y square minus 0. Now here what we need to do, here we need to show that this absolute value is what? Less than epsilon. At the same time, delta will follow this condition. Okay, therefore this we can write it as it is equal to further xy upon root x square plus y square. But what we have, we know that, but let me write here, but we know that what we know here, we know that absolute value of x is always less than or equal to root x square plus y square. Okay, as well as and again and absolute value of y is always less than or equal to x square plus y square. Okay, now here this one, by using this one, what we write here, this is equal to, let me write here, this is 1, let us call this as 1. Okay, therefore, what happened? This will happen at absolute value of x into absolute value of y over root x square plus y square. Okay, and this is less than or equal to absolute value of x is less than or equal to root x square plus y square. Again, absolute value of y is less than or equal to root x square plus y square, and therefore absolute value of x into absolute value of y, it will be product of these two, and what it gives me, x square, okay, plus y square over this as it is root x square plus y square. And now if have here this one, this is nothing but which is say equal to, right, equal to root x square plus y square. Okay, this is what we have. Therefore, we come across, therefore, what happened here? Absolute value of 1, f of xy minus 0 is what? Less than or equal to root x square plus y square. Okay, and this what we want, it is what? Less than, this one, less than epsilon. Okay, this is there. When if 0 is less than root, what happened here? Yeah, x minus, our point is what? AB, value of A is 0, value of B is 0. Therefore, x minus 0 square plus y minus 0 square, okay, which is what? Less than delta. Okay. Now here, what we have? This is nothing but what? As per the definition of what? Deleted delta neighborhood of point 0, 0, which is what? Greater than 0 and less than delta. If we have deleted neighborhood of 0, 0, okay, then we can find out what? Then we can have absolute value of xy minus 0, which is less than epsilon, and therefore by the definition of what? Limit. What we have done here, for every epsilon greater than 0, there exists delta greater than 0 such that absolute value of f of xy minus 0 is less than epsilon whenever or if 0 is less than root x minus 0 square plus y minus 0 square less than delta. Okay, and by using this one, therefore what we write here, therefore what we write here, therefore limit xy tends to 0, 0 of xy upon root x square plus y square is equal to 0. Okay, this is what? This is yes, shown. Okay, here in this way we can use the definition of limit, what we call it as epsilon delta definition, to show that limit of a given function exists and it is equal to the given number. Okay, now let us again go for the second example. Let me write here number 2. F of xy is equal to x square into bracket x plus y divided by x square plus y square. Okay, where this is there, if what? If both x and y are not 0 and value of this function is 0 if x and y both are 0. This is given to you. Okay, now the question is that find limit find limit of xy f of xy as xy tends to 0, 0. Okay, this is the question. Okay, this is the question. Well, now let us go for this example. Solution. Again here, let's say epsilon greater than 0 be a given real number. Okay. And what we need to find out here, again, as usual, as you know the definition, absolute value of this function and its value is what? 0. Okay, at point 0, 0. And therefore, we need to consider absolute value of all these one. Okay, and before going to directly go for the definition of absolute value, as we know, or let us use the given conditions or given things that we are always using or knowing from our algebraic sense or from our mathematical sense. Okay, now here we know that what I know, x square is always less than or equal to x square plus y square. Okay, x square is always less than or equal to x square plus y square. Of course, y square is, how is this one? Is greater or equal to 0, then this condition will hold. Now, from this one, we can have x square is less than or equal to x square plus y square. What this implies to me, if I divide both sides by x square plus y square, then what I am getting, x square upon x square plus y square is less than or equal to 1. Okay, and now this thing we are going to use, okay, in our expression somewhere else. I need this one. For example, if you look at this one and the given function, then you will find this there, x square upon x square plus y square, and we come across x square upon x square plus y square. Therefore, there is some relation between this and the given function, and that's why we are going to use this one. Well, now consider, okay, let us consider the thing, absolute value of f of xy minus 0, which is equal to, right, absolute value of, right, x square into bracket x plus y upon x square plus y square. This is nothing but what? Absolute value of x square, okay, upon x square plus y square, okay, into what? X plus y, okay, which is equal to, for the, again we have written the same thing, there is no need to write again. Let me write this here as it is, here in this way, into absolute value of x plus y. Now here at this instant, let us use this one. Okay, therefore this is 1, x square upon x square plus y square is less than or equal to 1. Square is positive, square is positive, square is positive, and as everything is positive, therefore where the absolute value of this one is less than or equal to 1, absolute value of this one is less than or equal to 1, and hence it is less than or equal to, here is 1, this is what we have here, 1 into this, which is what? X plus y. Okay, since y, right? Since y, 1. Now, again by triangle inequality, which we have had in first year BSc. Okay. Again by triangle inequality, what happens here? Absolute value of x plus y is less than or equal to what? Absolute value of x plus absolute value of y. This I know from what first year BSc, and what we have calculus, particularly, yeah, triangle inequality. Okay, this is what we have there. Okay. Now, I need to say this is what, so this is less than epsilon, okay, and therefore, absolute value of x will be less than epsilon by 2, and absolute value of y will be less than epsilon by 2, both here. If this is less than epsilon by 2, this is less than epsilon by 2, then the addition will be less than epsilon. That we know right from the algebra. Okay, and hence what we write here, this thing can be written as, now here in the first example we have used the circular neighborhood of a point 0, 0, and now at this example, here in this example we are going to use square delta neighborhood or square deleted delta neighborhood of a point, okay, 0, 0. Okay, this one, that is what? That is 0 is what? Less than x minus 0, okay, is less than epsilon by 2, and what happened here? 0 is less than absolute value of y minus 0, which is less than epsilon by 2, and let me call this as what? Yeah, delta. This as what? Delta, or delta 1 and delta 2. Okay. And as you know, there is no need to call delta 1 and delta 2, as we have seen in the definition. This one less than delta, this is less than delta. And hence what we have done here, that, yeah, chosen epsilon positive, and we have obtained the value of, yeah, delta to be 1, epsilon by 2, so that absolute value of f of xy minus 0 will be less than what? Epsilon. And hence, again, therefore, by the definition, okay, for every epsilon greater than 0, there exists delta, which we have obtained to be epsilon by 2, which is what? Greater than 0. Why greater than 0? Because epsilon is positive, delta is what? Positive, even though it is what? Epsilon by 2. Okay, there exists delta greater than 0 such that, okay, what happens? Absolute value of f of xy, f of x comma y, okay, minus 0 less than epsilon if what we have shown here, x minus 0 less than delta, and 0 is less than y minus 0 less than delta. Okay, and hence by the definition, what we do here, or what we write, what this implies, limit x y tends to 0, 0 of f of xy, okay, is 0. Here in this way, we can have the answer for our problem, which is what? Limit xy tends to 0, 0 of f of xy is equal to 0. Well, now let us go for one more example again. Okay, let me read this one, and let us go for third example. Well, what is it? Let us take this example. Find limit x comma y tends to 0, 0 of f of xy, where fxy is equal to, function is treated, remember, x into sine 1 upon y plus y into sine 1 upon x. When this is there, if both x and y not 0, okay, and this is equal to 0 if both x and y is 0, okay. This is an example given to us. Now let us go for solving this one, okay. Now as usual, let us have this one third example. Therefore have a solution of it one. Let epsilon greater than 0 be any given, okay, real number, okay, and consider absolute value of f of xy minus its value is 0, therefore 0 is equal to what? This function, that is what? X sine of 1 over y plus y into sine of 1 over x, okay, minus 0. Okay, you may write 0 or may not write 0, but whenever you are going to solve, as usual, your example, you need to write at least at the first step, which is what? 0. Okay, this is equal to, further this is equal to absolute value of, yeah, this is there. Now let me write directly less than or equal to, because say this is what our capital X, this is our capital Y, then by using triangle inequality, we can write it as what? Less equal X, what? Sine 1 over X, okay, plus Y into sine 1 over, okay, here is Y, sorry, 1 over Y and here is 1 over X, okay. Now which is equal to, actually, this is equal to absolute value of X into absolute value of sine 1 over Y plus absolute value of Y into absolute value of sine 1 over X, right? This is what you have. Means what? Actually what we are here, absolute value of f of x minus 0 is less than or equal to absolute value of x into absolute value of sine 1 over y plus absolute value of y into absolute value of sine 1 over x. Okay. Now, but let me write here, but we know that absolute value of sine x, okay, is less than or equal to 1 for every x, and therefore this becomes, therefore what it becomes, absolute value of f of x comma y minus 0 is less than or equal to, what happens here? Okay, this is what 1 and this is again 1, therefore it is nothing but absolute value of x plus absolute value of y. Okay, and now what we have here, as usual here in the previous example, we have said that this is what? Less than epsilon. This will be less than epsilon if what? 0 is less than absolute value of x minus 0 less than what? Epsilon by 2, and 0 less than y minus 0 less than epsilon by 2. Okay, and here this is what our delta, this is also our delta, and therefore for every epsilon greater than 0 we have obtained delta, okay, which is equal to epsilon by 2, which is positive, such that absolute value of f of x comma y minus 0 less than epsilon, okay, wherever or if 0 is less than absolute value of x minus 0 less than delta, and 0 is less than y minus 0 less than delta, and this is what? This is our, yeah, it is nothing but what? Square delta neighborhood. We are using square delta neighborhood. Okay, and hence, therefore, as usual here, therefore, what happened? Therefore, limit. Let me write. Therefore, limit x tends to x y tends to 0, 0. of f of xy is what we are getting. This we are getting, yeah, it is equal to 0. This is what we have. The third example here given this way, which here the function consists of what? Trigonometric functions. Okay. Trigonometric function, which is nothing but what? Sine. Right? Then let me go for, if possible, let us take one more example so that we can have here the idea about the limit of function of what? Two variables. Okay. Again, let us take the example. For the one, let us have f of xy is equal to, f of xy is again in splitted form, xy into, once again the trigonometric function it is given to you, x square, 1 over x square plus y square, if x and y both are not 0, and it is equal to 0 if both x and y are 0, and the question is what? Find the limit. Okay. Well, then can anybody tell me how to start? Okay. As usual. Well, let epsilon greater than 0 be any given, okay, number. Well, and what we do? Consider. Okay, what consider? Absolute value of f of xy minus 0. Why 0? Because value of the given function when x and y are 0 is what? 0, and therefore its limit should come up to be 0. That we are going to assume or consider first. Okay, therefore it is nothing but what? Xy sine 1 over what? X square plus y square minus 0. Right? This is further equal to what? Absolute value of, let me write directly, absolute value of what? X into absolute value of y into absolute value of sine 1 over x square plus y square. Right? By using the inequalities and all these things. Right? Now, again here we are going to use what in that? As we know that since yes, sine of x, absolute value of sine of x is less than or equal to 1 for every x, and therefore this is, it means what? This is actually what? Absolute value of f of xy minus 0 is less than or equal to what? Absolute value of x into absolute value of y. Right? And this is equal to, I know that what? Absolute value of x is less than or equal to root x square plus y square, and absolute value of y is again less than or equal to root x square plus y square, and this is equal to, therefore, which is what? Equal to what? X square plus y square. Okay, by using the inequalities which we know previously. Okay, and therefore this now, which is what? Less than epsilon. Right? This is what? Less than epsilon. You can have here, this is less than epsilon. Okay. Now from this one, this thing, there itself. Okay. This implies this x square plus y square is less than epsilon. Therefore, what happened to this? X square root x square plus y square is less than, what happened? Here we have considered the root. Okay, and therefore take a root of this one. This is what? Root epsilon. Okay. Now this we can write it as, that is, how to write this? Root, x minus 0 square plus y minus 0 square, which is what? Less than root epsilon. Okay. And here root is less than root epsilon. This quantity is less than root epsilon. Epsilon is positive, and we know that root exists if it is what? If the quantity under square root is what? Positive, and hence whole this one is positive. Therefore, what happened here? 0 is less than root, x minus 0 square plus y minus 0 square less than See here, 0 is less than root x minus 0 square plus y minus 0 square less than delta, which is equal to what? Root epsilon. Okay. And hence, what happened? For every epsilon greater than 0, there is a delta greater than 0, so that, yeah, absolute value of f of x y minus 0 less than epsilon. If this happens, root 0 is less than root x square plus y square less than delta, or whole this one is there, and what this implies, limit xy tends to 0, 0 of f of xy is equal to 0, and hence we have the answer for the given problem as what? 0. Now, here in this way, we can use the definition to solve the problems. Right? Now, next part we will see to the next lecture.